So riser function as described earlier. So when I discussed with you the steps involved in the casting, I discussed also at the last defect. What are the steps I told? Now all of you must be remembering here. Please, you can visualize. First is the metal is to be melted in the furnace. Second is molten metal is to be poured with the help of ladle to the mold cavity. Then third one is this molten metal is allowed to solidify. Some time is given to solidify. But during solidification, generally metal will shrink. And once metal will shrink, now what will happen? This we discussed in the last class. When metal will shrink, after shrinking, the level in the cavity of the metal will become lesser. See, if the level was supposed up to here, if it has become to less up to here, now your dimension reduced. Now your dimension is reduced. Because of this reducing this dimension, dimensional accuracy lost. That is why the riser is provided in the casting, and riser is nothing, it is a reservoir of the molten metal. So as soon as the level of the molten metal goes down from the riser, this molten metal will come and make the level good. Make the level good. So this is the function of the riser. So as described, riser is used in the sand casting to feed the molten metal in the casting during freezing. Whenever the metal freeze, it compensates during solidification process shrinkage. What is purpose of the riser? Riser is used in the sand casting to feed the liquid metal during solidification process or during freezing process of the metal. Whatever amount material get shrink, that much amount of the metal is given by the riser. Now riser, there are different forms of riser. What is riser? Understood the purpose? Please once visualize. Riser is a reservoir of the molten metal. Whenever during solidification, material shrinks, the level of material becomes less in the cavity, this riser will supply the molten metal to that cavity. So you will get the sound casting. This is the function of the riser. You can see here clear by this figure. This figure, it is clear. Now you see here. This is the riser. This is the riser. What is this? This is the riser. Now this riser, see here, this is called pouring basin. And from here, from ladle, it will be poured. Here is the ladle. And from here, it is poured in the pouring basin. This from where this is the passage of the metal, this is called a sprue. Please remember, this passage of the metal is called a sprue. And this horizontal pipeline is called runner. And with the runner, it is going here. This is your casting, this is your mold. Here is the mold cavity. Material get filled, and from runner, metal will go to the riser also. And metal has gone to riser. And it is now kept fill up to here. As level is up to here, it will be also go up to here. So riser is having now metal, molten metal. Molten metal is flowing from here to the mold casting. Here castings, this is the casting. In this one cavity will be there, in the cavity it is going. Now when this cavity or during solidification it gets shrink, the molten metal will come from here to here to serve the purpose. That is the purpose of the riser. What is the purpose of riser? The purpose of riser is to provide the molten metal during solidification whenever the shrinkage occurs. That is the purpose of the riser. Molten metal once get filled, so that dimensional accuracy will be achieved. Riser design. So very nice sentence you please remember. Riser is defined as the reservoir for supplying the molten metal to the compensate shrinkage. Generally shape of the riser, while designing whatever riser shape you will give, it is kept always cylindrical. Why? Because the volume filled in the cylindrical to solidify will take more time than the other cube shape or sphere shape. And our basic, this here science is involved, we should ensure that riser is designed in such a way so that riser metal should solidify at the last. First, casting metal should be solidified. And if shrinkage occurs from riser, metal will come and you will feed it. Thus, design consideration, how much volume of riser you should design. Suppose a metal in this casting, A volume, metal will get shrink. So you must make the capacity of the riser 3 times. 3 times the shrinkage volume of the metal. That is should be the volume of your riser. Cylindrical, pi d square by 4 multiplied by its height of the riser. It's very easy to design. Like that much should be the volume. How much should be the volume of the riser? 3 times into shrinkage of the casting. And solidification time you should note down. The solidification time of riser should be greater than solidification time of the casting. First casting should get solidified, then riser. Position of the riser, you can keep the position on the top of the casting or side of the side. You can keep left side also, you can keep right side also of the casting. These design considerations are better. Gating system. Now the gating system. What is the gating system? Objective of the gating system. First of all, we should know what is meaning of the gating system. See, gating system is very, very important to study. Reason is this: metal is poured from gating system. Metal is poured from the ladle to the basin. After pouring into the basin, from basin it will move to the sprue. After the sprue it will run, and then generally in the sprue also at the below we make some very small reservoir like a well. So whatever the impurities from the metal which are coming along with the metal can settle down in the bottom in the well, and then it will move from there well 90° to horizontal direction in the runner, and from runner further in gates are there. From these in gate metal will go to different cavities. Each cavity, when it is entering through gate, it has to go. So this is that's why there is a necessity of designing the gating system properly. So gating system, whenever the material has entered from basin to the sprue to the runner, each place whenever it is, suppose from sprue it is entering inside the runner. Now sprue is the vertical, runner is the horizontal. What will happen? Material will move slow. So your gate should be such so that material should enter inside. You want to see this figure because in the gating system, which figure I have shown just now, I will go back to same figure. See here also, we are pouring the metal. We are pouring the metal. See here, any metal. We are pouring metal from here, and it is going through sprue. Then this is runner. Runner is here horizontal. This is the vertical. Now at this place a gate is required. And again this metal will enter from here one gate. Again there will be gate to enter in this one. So different gate, what should be the ratio of the gates? Whether what should be the area of the diameter of these gates? That is important. Always there is a relation. Velocity of the metal will increase or decrease on the basis of diameter of the pipe or gates. So while designing gating system, we must consider these points. Gating ratio, starting gate should be bigger. Afterwards gate should be, dia should be smaller.